and also drag. So to explain that, it's just going to work for our project very well because it's the most common airfoil. So after printing it, you are going to glue it to a piece of wood, but you can also use a sheet of aluminum or even cardboard because it's easier to cut afterwards. The next step is to measure the sheets of foam to make the wings, and also use common sense just to make the sizes correct, because if you make the wings too short or too large, are going to be a pain. So just make sure everything is good size, so just use common sense. Now the measurement that I used is 75 centimeters for the span of the wing, because that's the size of the foam coater that I have. So if I make them larger than that, I won't be able to cut the wings, or I will have to cut the wings in parts. After marking the wings on the sheet of foam, we're going to use a knife because it's the simplest way to cut the wings out of the sheet of foam, because if you use the foam coater, that's just a pain and it's not worth it. So just use a knife. Then we're going to place the templates on each side of the wing, and we're going to secure them using maybe sticks or pins, or maybe glue them on the wings just to make sure they are there and they're not gonna fall off while cutting the wing, because that's gonna screw it up. So then we're going to use the electric coater. You can make one at home, or even if you're lazy and don't want to make a foam coater, you can also do it with, cutting the wing with a knife and then using sandpaper to finish it off and make the wing profile the same way. That will take a lot more time and also be a pain in the neck, so I will suggest you to build a foam coater. Now I'm going to show you how is the correct way to cut the foam. Because I'm holding the sheet of foam with my hands, this is creating a bend, so the cut is not straight and the wing is not a wing, it's just a piece of garbage. So what you have to do is place the sheet of foam in a flat surface and use the coater in your hand, so the coater is the one that's going to move and not the wing. I put some guide sticks on the trailing edge because that's easier to place the cutter in the right position, and that way we're less likely to make mistakes, so that's a little help. After we have finished the wing, we're going to use tape to cover it, because that's going to make it more aerodynamic and also very smooth and very cool. So we can use packaging tape, or also we can use a special tape that is for wings that comes in many colors, but to keep our budget very tight and very low, we can use any kind of tape. So finally I'm cutting the fuselage out of the sheet of foam, and I'm not gonna use any measurements for this, it's just using common sense. And then I'm going to make a hole for the wing, so the wing is going to pass right in the middle of the fuselage. That's gonna make the attachment between the fuselage and the wing stronger, but also I'm going to use glue and maybe a stick, so I can put the stick through the foam, so it would be like a pillar inside the wing and the fuselage. The wing doesn't have to be there, but you can choose to put the wing on top of the fuselage or under the fuselage, and that's up to you. Even you can make a small dihedral that's gonna make the airplane more stable in flight. Now remember the stick of wood that I bought? Well, that's going to be in the middle of the wing, so that will reinforce the wing and make it stronger. Now that stick of wood is too heavy, and also I think it's too big and it's too much for this wing, because these airplanes are not gonna be stressed in high G's or high forces. The wing is gonna stand these things very well even without the stick of wood. So even a small stick of wood is gonna work very well, so you can get away with it for a small airplane. But if you are making a big airplane, or you're going to make a very fast airplane, then you have to put something very strong. Otherwise, when you make a loop or you turn the airplane very fast, you're gonna snap the wings in the middle. Now that we have put together the wing and the fuselage, it's time to put the stabilizers. The stabilizers are very easy and it doesn't require any longer explanation, but just put some glue, and also you can put some sticks in the foam just to make it stronger. Okay boys, it's time to put the ailerons. We're going to make the ailerons out of cardboard. Yes, cardboard is okay, but you can also use balsa wood or any fancy material if you want. But cardboard works well for this project because it's gonna be very good for my pocket. So I'm going to cut the ailerons and put them with tape. Now I'm using tape all along the wing, but you can also put just in 3 spots in the wing, so it won't make a lot of resistance for the servos. The micro servos are not too strong, so it's better to make the job easier for them. The same that I did for the ailerons applies for the elevator and rudder. The rudder is often wider than the rest of the control surfaces of the airplane. Now we're going to use a can of soda and use the aluminum from it to make the control horns that are going to be on the control surfaces of the airplane, like the ailerons, elevator and rudder. So I'm going to cut it with a pair of scissors, and then I'm going to make a very tiny hole where I'm going to connect all the push rods that are going to simply be a string of a guitar, a metal string of a guitar. Before gluing the control horns on the control surfaces or the ailerons, we're going to lay out the servos and measure the distance of the servos from the receiver, so we make sure the cable is long enough to be connected to the receiver. So that way we're going to know exactly where the servos are going to be, and that way we're going to place the control horns and glue them in place. Now it's time to put the servos on the wings and the other places of the airplane. It's easy when you have the servos laid out on the surfaces, so you have to make a hole with a knife and just put the servos in and glue them in place, or just even put some tape on top and that's gonna hold them in place. Now if you're lazy, you can even leave the servos outside and just put some tape, and that's gonna work as well, but it's not gonna be aerodynamic for the airplane. Try to avoid using servo extensions because that's gonna make the airplane heavier, so you can save few grams on the weight, and that's gonna make the airplane behave a lot better in the air. Now for the elevator and the rudder, I had to put the servos in the tail, so that means that I'm going to use some servo extensions for them, and that's gonna make the tail heavier, and to compensate that I have to put some weight on the nose, and that's gonna make the overall weight of the airplane heavier. But that's okay, it's not too much, but if you can avoid that with a pull-pull system or something lighter, putting the servos closer to the wing, that's gonna make the airplane better. But everybody prefers to put the servos on the tail because it's easier to connect and also to set it up. Always power on your system and center the trims so you can know where the neutral or center point of the servo is while connecting the servo arms and the push rods. Now I'm done with the servos, and now it's time to put the motor in place and the rest of the electronics as the battery. But I have to do some soldering for that, and then I have to prepare some epoxy glue to put the motor in the nose of the airplane. I did try to make a landing gear for this airplane, but it didn't work, and I just leave it alone and I'm flying the airplane without the landing gear. Alright, at this point we're almost ready. We just have to put the battery and power up the system and just polish it to make it fly. The last thing we have to do is program the radio so every control surface is in good working condition, and also do some tests, and we're ready to take this thing to fly. So here we are in the maiden flight. The motor is on the nose of the airplane to balance the CG of the airplane, but that means that the propeller can be damaged on every landing. So I'm using a prop saver that is just a rubber band that it's going to snap or just fall off every time it crashes. So because the heaviest component of the airplane is the battery often goes on the nose of the airplane, and we can move it to achieve the desired CG of the airplane. So after this we have to do some tests. And on the test flights, anything can happen, like crashing all the time. But after some calibrations and tests, everything is going to work out. If you liked the video, help me out and hit that subscribe button and also push the like button. So see you in the next flight, and thanks for watching.